Okay, we're back. If you haven't already, please make sure that you watch lesson 25 part 1 first before watching this. This is lesson 25 part 2. So in part 1 we just went over factoring out a GCF, or greatest common factor, and we're going to pick up with that concept and kind of build on it and do something called factor by grouping. All right, so what if there is no GCF in a polynomial with 4 terms? So first thing that you'll notice is the grouping problems we will see always have 4 terms. And what we're going to be doing is breaking them down into groups of 2 terms each. All right, so here's the general process. Break into 2 groups of 2 terms each. Then factor out the GCF from each group. So kind of like you're doing 2 little problems separately. Your final answer should be the product of 2 binomials. So I will just backspace a little bit here and just remind you of what you saw recently in part 1. I'm going to go to a previous slide for a second here. Remember this one with the R and the Z, and then how we had the Y minus 3 in common? That's going to be what we will be seeing, not as a first step, but as maybe a second step of a grouping problem. We're going to notice a GCF, it's just that it's going to be in parentheses. And your final answer for most grouping problems will look something like this, where you have parentheses with 2 terms times parentheses with another 2 terms. Okay, just wanted to remind you of that. Let's go back. Oops, okay, too far. Number 1, all right, so RT plus RX plus NT plus NX. So if your directions just said to factor out a GCF, if you look carefully, there is no GCF between all 4 terms. The first term has R and T. The last term doesn't have either of those things. So I couldn't factor out something from all 4 terms. However, we're going to break the problem into 2 groups. So there's different ways of showing this. A lot of times people use parentheses. I'm going to prefer to use sort of an underlining process. Just do whatever works for you. So I like to do a little brackets like this. I don't really like parentheses because then it does make it look like a FOIL problem. So I'll just briefly show you what I mean so you can recognize it when you see it. So here's what you'll see sometimes. You'll see this. This is fine. Okay, that's great. Again, the reason why I don't like it as much is it makes it look like a multiplication or FOIL problem, which it's definitely not. Okay, but as always, show work in a way that makes sense to you, which is what I'm going to do for myself as well. All right, so find a way to show that you're splitting the 4 terms up into 2 groups of 2 terms each. All right. Now we get to treat each group as its own separate problem. So let's start with the first group, RT plus RX. Between these 2 terms, there is a common factor of R. And now what's left over, if I divide each of those terms by R, RT divided by R is just T, plus RX divided by R is just X. That right there is just a little mini GCF problem, little greatest common factor problem. Now we're going to do another one over here, NT plus NX. What's the GCF between those terms? This time it's N. And I am going to write a plus. That's going to become relevant in a little bit here. So if you're factoring out a positive in a grouping problem, just put a plus sign. Sometimes we'll factor out a negative. We'll get there. But again, between these 2 terms, the greatest common factor is N. Divide each of those terms by N. NT divided by N is just T, plus NX divided by N is X. Okay, so again, one more time, I'm going to show you how similar this should now look to a problem we saw in part 1. So I'm going to a previous slide one more time. Right here. Okay, so we're kind of right here where there's something in parentheses that is the same, and we're about to write our final answer looking like 2 binomials. So let's do that. All right, so the t plus x, that is a GCF. So the GCF, greatest common factor now, is t plus x. So let's take that out, meaning let's write it. Now what's left over? Well, what's kind of in red here? These sort of outside terms that are outside the parentheses, those are what are left. So we have, in parentheses, we have r plus n. This is my final factored answer. Now let's see what it looks like to check. I've been mentioning that checking is an option, but I haven't really been doing it. But let's check. And when we check our answer, it will look like we're doing FOIL, meaning we're distributing. So let's take this expression, this answer, and let's FOIL. Let's multiply these together and see if we end up getting the original problem. So let's do that. T times r, that's TR, plus T times n, that's TN. Okay, so this is what I just did. My first outside, and now we'll do inside terms. X times r, that's XR, plus my last two terms, x times n, xn. Okay, so does that look the same as the original problem? I mean, yes and no, right? So there's some rearranging we can do. Instead of TR, we know that that can be written as RT if we wanted to. And let's see, do we have an RX term? I mean, we kind of do right here, XR. I can write it as RX. So I'm doing some rearranging of the order here, which is fine. That's called the commutative property. So I can definitely rearrange the order and the answer is still equivalent. Do I have an NT? Well, I have a TN. So I can rewrite that as NT plus. Do I have this NX? Well, I had XN. I can write NX. So it's the same. Okay, so it checks out. Those expressions are equivalent or equal to each other. So that's what it looks like to check a grouping problem. All right, so that was number one. That might have been the very first time you saw anything like that. Let's continue and do a few more. We'll look at number 2 and number 3. Okay, number 2, same idea. We have 4 terms. There is no GCF between all 4 terms. The first 3 terms have an A, but the last one doesn't. So factoring out an A just from the first 3 is not helpful. Don't do that, okay? So either for a GCF, either factor it out of the whole thing, or if you can't do that, try grouping, and that's what we're going to do. So now we took our 4 terms and broke them into 2 groups of 2. Let's look at the first group, a to the 5th minus 7a to the 4th. The GCF there is a to the 4th, because remember, if you have the same variable between your terms, factor out the one with the smallest exponent. Now we can take each of these original terms and divide them by a to the 4th. Let's see what's left over. A to the 5th divided by a to the 4th is just a, because we can subtract exponents. 5 minus 4 is 1, so it's really a to the 1 minus 7a to the 4th divided by a to the 4th is just 7. So I'm left with just a minus 7 in parentheses. Now let's move to the second group. This might be a little confusing at first glance because you might not know what to do. Plus a minus 7. So I'm looking for a GCF, or a greatest common factor. What is it? What do they have in common? If it feels like they have nothing in common, that means it's a 1. Okay, so it's not nothing. They don't have nothing in common. There's always a common factor of 1, and we often forget that. And I definitely need to write that 1. That is a necessary part of my final answer, to have a 1 here. So once again, if you're factoring by grouping and you're looking at these 2 terms and they don't seem to have any common factors, they really do, it's a 1. And now when I factor out a 1, you're essentially dividing each term by 1. A divided by 1 is just a. Minus 7 divided by 1 is still minus 7. Now notice these parentheses, they match, they're the same. That's your GCF, a minus 7. And then what's left over, and again, I'm keeping them in 2 colors just to help you keep track of what's going on. Do that on your own too if you need to every time. Okay, what's left over on the outside of parentheses, a to the 4th plus 1, that goes in your second set of parentheses. And once again, you can definitely check this by FOIL if you would like. So check using FOIL. Okay, so I'll do that. A times a to the 4th, that's a to the 5th. A times 1 is just 1a, or a. Minus 7 times a to the 4th is minus 7a to the 4th. Negative 7 times 1 is negative 7. So take a look at those 4 terms. It's almost the same as the original problem. It's just that our order has been rearranged a little bit, and that is okay. Instead of the minus 7a to the 4th, I have the a before the minus 7a to the 4th, which is fine. What you're checking is that all 4 terms are there as you're distributing. All right. Good. Number 3. I'll just let you know right now, this one will involve factoring out a negative when we get to that second group. Okay, so once again, there's no GCF between all 4 terms. The first 3 have x, but the last one does not. 5 goes into 30, 6 goes into 30, but there's nothing here that goes into 30 other than 1. 6 and 5 have nothing in common. So there's kind of common factors throughout, but there's nothing in common with all 4 terms. So once again, break your problem into 2 groups of 2 terms each. And we're going to factor out a GCF from each group. X to the 3rd plus 6x squared. What they have in common is x squared, because they both have x, and we'll take the smallest exponent. Now, when we divide each of those terms by x squared, here's what we have left. X to the 3rd divided by x squared is just x, plus 6x squared divided by x squared is just 6. Moving on to the second group. Now, by now we've done a few of these. You should see kind of a pattern here. What we see in the parentheses, what I've been writing in blue, it should match every time. If it does not, then you did something wrong or a mistake was made and we need to go back and fix it. So I guess what I'm saying is I'm expecting x plus 6. That's what I'm expecting to happen here. Now, how is that negative 30 going to be factored and then turned into a positive 6? How's that going to happen? Well, we're going to need to factor out a negative. That's really what we need to do. So let's back up a moment here. Okay, let's just look at this second group as its own problem. Negative 5x minus 30. And yes, I'm calling this negative. I know it's minus 5x. Negative and minus, as you've maybe started to see, they're kind of the same thing. Okay, so treat this as a negative 5x. Treat it like it's the first term in your problem. It's the first term in this little mini group here. Factor out a negative. Now that we know we're factoring out a negative, we can focus on what these 2 terms have in common. 5 goes into 30, so we can factor out a 5. What we're really factoring out is negative 5. Every time you have that situation in a grouping problem, if you kind of see that minus sign in the middle of the problem, plan on factoring out a negative when you get to that second group. And now it should work out really nicely. Negative 5x divided by negative 5 is just positive x. Negative 30 divided by negative 5, there's that positive 6 that we wanted. So if we had done it differently, if we had factored out just a 5, we'd be left with negative x minus 6, which wouldn't match, and we'd be kind of stuck. Okay, so you would not be able to keep going with your grouping problem. So we don't really want to do that. Instead, we definitely want to factor out a negative here. Okay, good. I think we're ready to write our final answer. Our common factor is in parentheses, this x plus 6. And then in my second set of parentheses will be the x squared minus 5. Usually by now I've gotten the question, does it matter which order I write the answer? Not really, no. But there's still a lot of details to keep track of and things that you do want to be careful of. So I'll show you, here's another way that you can write this answer. You could write the x squared minus 5 first, and then the x plus 6. So I'll just say or. Oops, go back. Sorry about that. Okay, yes, so does the order matter? There's a lot of things that matter here. So the only thing that should have a minus sign is this 5. The x squared definitely needs to go with the 5. The x needs to go with the 6. However, the x plus 6 as a factor in parentheses, that doesn't necessarily need to be written first. It could be written second. And then the x squared minus 5 could be written first instead. So as long as you have these two exact factors, the order that you write them can be reversed. If you haven't noticed already, I tend to like kind of having a routine and having a system that I can follow. It's sort of comforting, and it can help with these longer problems. So what I am used to doing is taking the common factor in parentheses and making that the thing that I write first. I will say most or all of the time, but you don't have to do it in that order. Okay, good. So we're about to move on to seeing some problems where it says factor completely. Okay, factor completely, that usually means that there's more than one kind of factoring. Okay, so we're always factoring completely. It's just like when we reduce a fraction, we always want to reduce it completely. We don't want to stop halfway through, but this is usually a clue that there's a GCF to take out first. There's an extra step. I'll say there's more than one type of factoring. And you really only know two at this point, GCF and grouping, but you're going to learn some more. So this phrase, you'll see it throughout this whole unit, factor completely. So let's be really careful here for number 1. By now you're maybe sort of being trained to, maybe you've already started grouping. Maybe you're already working ahead of me. If that's the case, I would say stop. And I want you to notice that in this problem, there is actually a GCF with all 4 terms. 12, 36, 15, and 45. If we were to make a factor tree for each one, they do all have a common factor of 3. Okay, and if making a factor tree seems too overwhelming, pick a number that's easy to break down, like 15, 3 times 5. I'm not even going to bother breaking down the other ones because 15 is the easiest one for me to factor just at first glance. All I need to do is check, okay, does 5 go into all of these terms? Is that a GCF? No, 5 doesn't go into 12, so I don't need to check the others. Does 3 go into all of these? Okay, I know 12 is a multiple of 3. If I check, I also know that 36 is a multiple of 3. So 12 divided by 3, that works. 36 divided by 3, that's 12. 15 divided by 3, so far so good, it's working out. 45 divided by 3, that's 15. Okay, so 3 does go into all of these numbers. So that is our GCF of the entire problem. Okay, so here's how I will show that, because after we take that out, we will still need to do the grouping process. And I'm making some room here. Okay, because I know that parentheses are coming in what we're about to do, I like to use brackets when we take out this 3. So we'll take out the GCF of 3, which means each of these terms will now be divided by 3. 12 divided by 3 is 4. Now I didn't take out any factors of r because the 45 didn't have any r. So all the r's are staying the same for now. 36 divided by 3 is 12. 15 divided by 3 is 5, r squared. 45 divided by 3 is 15. Okay. Now we still have a whole problem to do. So this 3 is going to be part of our final answer, but chances are we might forget about it as we're working. So I recommend that as soon as you take out a GCF like this, just bring it down, write it in your final answer so you don't forget later. And that would be a frustrating reason to get a problem wrong, that you just forgot to write the 3 in the answer, because it's absolutely part of our final answer. Okay, now that we've taken out the GCF, now we can just treat what's left here in red as its own problem. That's now a grouping problem. So now we can just kind of proceed as we were doing before. Okay, so here are my different groups. 4r to the third plus 12r. That's what I'm focusing on right now. Again, we already took out the 3, so it's all good. We took care of that. Don't need to worry about it. It's ready for us in the answer. Just focus on this group, 4r to the third plus 12r. Now, these two terms do have something in common. 4 does go into 12, so 4, and then between the r's, the lowest exponent is this just r with the 12. So 4r is our GCF. What's left over now? 4r to the third divided by 4r, that would be 1 and then r squared, right? Because I'm subtracting the exponents, that's really a 1 here. Plus 12r divided by 4r, that's just 3. Not 3r, the r's cancel. Okay, it's just 3. So what I should expect is r squared plus 3 will probably go in one of these spaces in my final answer. I'm going to wait on that though, but that's what I'm expecting. Now moving to the second group, negative 5r squared minus 15. Once again, I'm going to factor out a negative. We've seen that before. 5 goes into 15, so that's my GCF. The 15 doesn't have any r with it, so I'm not taking out an r, just taking out a minus 5. Negative divided by negative is positive. So negative 5r squared divided by negative 5 is just r squared. Negative 15 divided by negative 5, that's positive 3. So here we go. Here's our greatest common factor in our grouping problem here. The r squared plus 3. Right here. And then look at our outside terms. The 4r minus 5, those come together here. And there's that 3 that was waiting for us. So this is what it looks like to factor completely. We had 2 different types of factoring. We had to take out a GCF, and then we did grouping. Now, here's the reality. It's very possible that you would not have noticed the GCF. A lot of times we don't notice it. We just kind of dive right into whatever we think we need to do. So I'm going to do this problem again. You don't necessarily need this, but I do think it would be good to see, because inevitably this will happen where there's a GCF, but you don't realize it. So I don't want you to think you have to start all over if that happens. Let's say you did not notice the GCF. Okay, and let's say we just immediately started grouping like this. Okay, so here's my first group, 12r to the third plus 36r. So 12r would be my, oh, not squared, sorry, just 12r. 12 goes into 36. And actually, maybe you didn't even know that 12 went into 36. That's okay. What if you didn't realize that? What if you said maybe 6? Maybe you said 6r instead. 6r. Then you're left with what? 2r squared plus 36 divided by 6 is 6. Okay, if this happens, notice in the parentheses, the 2r squared plus 6, they have a 2 in common. That means we missed a 2. Oops. We missed a 2 when taking out a GCF. So 6 wasn't it. We have to go higher. 6 times 2 actually should be 12. So that will also happen sometimes if it hasn't already. Okay, so now I'm doing a lot of erasing here. I can't show you every possible error, but there's some that are common enough that I feel that it's important to kind of warn you about. Okay, so here we are. We now know the GCF is 12R. And what's left over is, let's see, R squared plus 36 divided by 12 is 3. Next group, minus 15R squared minus 45. Okay, 15 does go into 45, so I would take out a 15 and I can see it's negative, so I'm going to write minus 15. And then we're left with R squared. Negative divided by negative is positive, and there's that 3. So you can see we still have the R squared plus 3. But it's the other factor that's going to be the problem. 12R minus 15. So if you circle that as your answer, it will not be marked right. There's something that we still need to do. We don't need to start all the way over, but this 12R minus 15, there's a GCF here, and the GCF is 3. So what you can do is take out the 3 right there. Okay, and then what's left over is the 4R minus 5. Meanwhile, the R squared plus 3 will still be there. Now that looks weird maybe to have it written in that order. So feel free then to rearrange it and write that 3 all the way out to the left. Okay, just gonna pause myself for a moment. All right, we're back. So we had just finished number 1, and now we're gonna move on to number 2. This is another problem where the directions are to factor completely. So once again, we do have a greatest common factor in all 4 terms. So it's important that we take that out first, and then we'll go ahead and factor by grouping. If you do the grouping part first, that's okay, but it's a little more likely that you'll forget about the GCF later, so it's better to take out the GCF as soon as you notice it. So in this case, all 4 terms have W, the smallest exponent. You can't even see it, it's a 1. So our smallest exponent is just W to the 1 or just W. So let's start by taking out W from all 4 terms. All right, so we're going to divide each term by W. And what that means is each of the exponents will essentially be subtracted or decreased by 1. So W to the 6th divided by W is now W to the 5th. W to the 4th divided by W is now W to the 3rd. And then this 3rd term, 3 minus 1, that becomes 2, so W squared. And then finally, W divided by W is just 1, because remember, anything divided by itself is equal to 1. If you think about subtracting exponents, it's just W to the 0, but instead we'll write 1. Okay, just like last time, after we take out the GCF, we're going to bring it down and write it as our final answer, as part of our final answer. Okay, so we know there's going to be 2 binomials, 2 expressions in parentheses, and now we also know that there's a W on the outside. So now that that's all taken care of, now we can go ahead and factor what we have left over. So we'll break it into groups. Okay, so we're splitting our 4 terms into 2 groups of 2. The first group has these 2 terms, W to the 5th minus W to the 3rd. Our smallest exponent is 3, so we'll take out W to the 3rd. What's left over is now W to the 2nd, or W squared, because 5 minus 3 is 2, so we'll have W squared minus W to the 3rd divided by W to the 3rd is 1. All right, moving on to the second group, W squared minus 1. It does not appear to have any common factors between the 2. The second term doesn't have any W. the first term doesn't have a coefficient other than 1. So remember, if it seems like there's nothing in common, you can always factor out a 1, which is exactly what we're going to do. W squared divided by 1 is just W squared. 1 divided by 1 is 1. All right, so our W squared minus 1 is our common factor. And then W to the third plus 1, those are the terms sort of left over on the outside. And that will go in our other parentheses. Okay, so I will say that if you happen to look up this problem somewhere else, it might tell you to go further than this. There are other kinds of factoring we will eventually learn about, but not today. So W squared minus 1, there is a way to break that down. That's something called the difference of squares. W to the third plus 1, we will eventually, not today, we will eventually learn a formula for factoring perfect cubes. Not today. So we're done. We took out a GCF, that was W, and then we were left with these 4 terms, and we were able to factor by grouping, breaking the 4 terms into 2 groups of 2, taking out a GCF of each one. And then our final answer, instead of just having our 2 parentheses, we also had that W on the outside. Okay, good. So seems we have made it to the end of our lesson 25. So we did part 1 in a different video that was factoring out of GCF. And then what we just finished, part 2, we did factoring by grouping. And these last few problems, we were factoring completely. And as we saw, factoring completely usually is just an indication that there's more than one step and more than one type of factoring. So in this last problem, we took out a GCF, and then we were also able to factor by grouping. All right, so that's all for now, and I will see you soon for lesson 26.